All right, we're going to take a look here, guys. It's a lot of vocabulary with functions and kind of reviewing that. So we take kind of this big concept of what is a function, and we give you a real quick review of that. We're going to use words like domain. Now, the thing is, it seems like we introduced domain here, and we talk a little bit about it now. What I remember is that we use domain and range a ton in Algebra 2B. So we're going to introduce this vocab word here, and then some of you won't see it until like next winter, okay? But domain is just the X variable, or it's your input values. All right, so I should be able to say what is the domain of the function, and you're able to tell me, well, these are the numbers I'm plugging in for X. Range then is the Y variable. Or it's our output values, which is why we always solve for Y. We want our output equals, and then we want the mathematics that we have to do to get our output. A relation is just a set of ordered pairs. So we could stand in the hallway between 3rd and 4th hour, ask every student to write down an ordered pair, and we created a relation. So any set of ordered pairs is a relation. What happens though, and what we like to study in algebra now, is specific types of relations, and those are functions. And so the function is where there's exactly one output for each input. So now the number of ordered pairs we can have is completely narrowed down. Because if it's a function, every time x is 2, in that ordered pair I should have the same y value. So if we were to have a function, that means every time we go in the hallway and we ask a student, okay, x is 2, all of them would give us the same y value. All right? And so in math, when we look at our y equals, that's why those create functions, because we always do the same arithmetic with the x value. Your independent variable is x, okay, or your domain, or your x variable is what it would be. All right? We can pick any x we want. But once I pick that x value, it influences what my y value is. So y is called the dependent variable. All right? I can't find y until you give me an x value. Y depends on my x. And then function notation, ladies and gentlemen, is this f of x. Don't want to put equals there. We'll put colon f of x is how we read it. And it said the function the function at x. And so what we start to see is, we'll see f of 2 equals -4. And so what that means is that the function at 2 is -4. So when I plugged in 2, my output was -4. It's a quick way of being able to see what your x is and what your y is. Now we use that a little bit today, ladies and gentlemen. We will also see it again later on in the week when we start talking about finding the slope of functions, is we're going to use this function notation there to understand what's going on. But the nice thing is as soon as I see this f of 2 or f of -3, I know it's a function. Okay, if someone asks me, is this a function? As soon as I see f, I know it's a function. All right, and so that's what we're going to spend the rest of this lesson on, is identifying functions. So remember, our rule was one output per input. So the input can only have one output. So when I start looking here, -3 goes to 3. Perfect, it only has one output. But what happens when we get to number 1, or to the 1? How many outputs does it have? 2. And so, ladies and gentlemen, we would look at this as not being a function, and then we have 4 to 4. Here we have 3 to 3, 1 to 1, 3 to 1, and 4 to 2. So when I look at this, each one only had one arrow coming out of it, so it looks like I'm able to identify my function from my non-function. But today in your homework, they're going to ask you some leading questions to help you figure that out. So the first thing they want you to do is to list the domain and to list the range. That's going to be kind of one of the first questions you have to list. It'll say, is it a function? Yes or no. List the domain and range. So in your notes today, we're just going to write it all as write domain and range for each of those. So the domain for A, we'll do A in red. The domain is your input value, so -3, 1, and 4. We only write them one time. And we usually write them from smallest to largest. My range for A, the smallest range value is -2, then 1, then 3, and then 4. So that's the domain and range for number 1. Or for letter A, I'm sorry. I want you guys to do B. I want you to list domain and range. So I want you guys to do that at your table. And I'll call on one of your groups to answer for me. Tyler, what do you guys have for the domain of B?
-3, 1, 4.
Ooh. Those are hard ones to split out. Eric, what do you guys have for the range? What? 1, 2, 3. All right. Ladies and gentlemen, they may also ask you to write them as coordinates. So if they list just the domain and range, we can't do that. I can't tell just from the domain and range what the coordinates are. So I have to have either a graph that has ordered pairs that I can write ordered, that has the points on it that I can write ordered pairs for, or it has an input-output table. And so for A, what this is going to look like is I'm going to take the input and pair it with its output. And then I'm going to take an input and pair it with its output. Because one had 2 outputs, I have to use that same x value again and write it with its next output. And then I've got to do the same thing. So, at your table with your partners, if you have not done so already, write the ordered. Lexi, what did your table mates and you come up with for coordinates? Oh, I better start recording. Oh, I did. -3, 3. 1, 1. 3, 1. 4, 2. Do we agree with Lexi's group, ladies and gentlemen? All right. Ladies and gentlemen, I believe we're doing some graphing next, correct?
Oh.
Yes, because that's what we're going to do a ton of that in chapter 2.
I like that.
All right. Ladies and gentlemen, we need to plot these points. So I'm going to start right over here. We'll call this A and this one B. So A is -3, 3. So we go back to 3 on the. Oh, these are backwards. I'm sorry. I found that in some of the notes and I didn't fix them. Y should be the vertical axis and X should be the horizontal. Sorry. Are they correct on your notes?
Yeah.
Oh, okay. They are just drawing in here. -3, 3 should be over here. 1, -2 should be down here. 1, 1 should be up here. So we've got these 2 dots, 2 points lining up, and then I've got 1, 2, 3, 4, 1, 2, 3, 4, which should be up here. For B, I should have -3, 3, 1, 1, 3, 1, and then 4, 2. All right. So what we've done here is we've looked at this graph in terms of its domain and range. We've looked at it in what we call an input-output table. We've looked at it as coordinates, and we've looked at it as a graph. What we want to be able to do is, based on our definition, which graph is a function and which is not, and how do we figure that out? So ladies and gentlemen, we kind of talked about that earlier when we looked at the table. Which of our tables was not a function? You guys remember which one we said was not the function? A. And why was A not the function? Because I can only have one output per input. What violated that rule? The 1 having 2 of them, right guys? So what does that look like then in terms of ordered pairs? Well, if we're given a list of ordered pairs, ladies and gentlemen, if X repeats, then that is not a function. If none of your x's repeat, then it is a function. If we look at the graph, if you have 2 points that line up vertically, we kind of call that the vertical line test. So if you have points that line up vertically, then that is not a function. And so that's how I can tell, not just from the table, because it's really obvious from the table. You've got 2 outputs. But now I know how to tell just from a set of coordinates, and I know how to tell from a graph which one is a function and which one is not. Okay? So guys, they give us a chance here to kind of draw in some examples of graphs that are not functions. I don't have a whole lot of room here. So if we were to look at graphs and tables that don't represent a function, if I had something like this, ladies and gentlemen, this is not a function. And the reason being is I can draw a vertical line through that graph, and it will hit at 2 points. So anytime my vertical line hits at 2 points, that is not a function. Right there are my rule violators. Another one that would not be a function, if we looked at a graph, if we had something like this. This is okay over here, guys. It's okay to have a horizontal line. But as soon as we draw in that vertical line and we hit the graph at more than 1 point, that is not a function because the vertical line hits at 3 points. Now today in your homework, you're going to say, okay, why is that graph not a function? You simply have to say, because a vertical line would hit the graph in more than 1 spot. I mean, that's all we're saying there. It's as easy to prove that with just your vertical line. All right, and then the tables, guys, I'm not going to have you draw one because we already have an example of a table that doesn't represent a function over here. Okay? Oops. Here's this first time to introduce you guys to this function notation. It says evaluate the given function for the given value of x. Remember, this is read as f of x, so that means -2 is your x value. And so the number in parentheses is what you're substituting for x. So this problem becomes 4 times -2 plus 2. So these aren't a whole lot different than what you guys were doing on your test, what you guys were doing in chapter 1, only now we're using this function notation. So now you just type it into your calculator, or you work it out using order of operations. I don't have my calculator with me, so I'm going to do -8 plus 2. And what's -8 plus 2? -6. But ladies and gentlemen, now that we know it's a function, we're going to write our functions using function notation. You're going to tell me the function at -2 equals -6. You're going to show me the input and the output in the same statement. Okay? I'm going to see input and output. So let's take a look at the next one. I need to take -2. This is my x. And so I'm plugging that in for x. So I have -5 plus 7 times -2. And then squared. Ladies and gentlemen, this is where some of you struggled quite a bit in chapter 1 with some of that order of operations. I have to square the -2 first. So this should be -5 plus 7 times 4, because -2 squared is 4. -5 plus 28 is 23. Now I'm going really quickly through that math, ladies and gentlemen. If you're having trouble keeping up, what can you use to help yourself? What did I say you guys could use? The calculator. And you guys can take this whole statement and type it in. But guess what you have to remember to put around your x value? You have to put those parentheses. But I'm not done. You're not just telling me that it equals 23. You're going to use your function notation. Guys, is your function notation already halfway in the problem for you? Yeah. All right. Ladies and gentlemen, I want you to try 3 and 4 on your own. I'm seeing a little bit of crazy stuff going on with number 4, and I'm seeing it across the whole class. Ladies and gentlemen, I'm not plugging anything over in on this side. I'm simply taking this 2 and plugging it in for x. And for some of you, I think that's going to be your safest bet, is to just simplify this right-hand side. So then I have 2 minus 3, negative 1. Absolute value of negative 1 is 1, and then the negative comes down. So I have an answer of negative 1. Now you're going to bring in your function notation. F at 2 equals negative 1. I'm never doing any division, guys. There's nothing over here to divide by. All this left-hand side ever does for you is tell you what number did you plug in for x. So now I go over here, ladies and gentlemen. Is there any x to plug in for? No. So this is just going to equal 3. But I saw some people doing this, 2x or 2x. That's not what we do. What goes over on this side? F at 2 equals 3. If there's nothing to plug in for x, guys, this is just going to be a constant. And so that means f of 2 is going to be 3. F of 4 is going to be 3. F of negative 100 is going to be 3. Okay? But this left-hand side is simply your function notation. Okay, guys? Your assignment is on the agenda. So get that back out. It is a book assignment. It is book assignments all week long, guys, so make sure you come prepared. Do you have any? How about this?
Yeah.
What?